Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1, Episode 15. Well, now that we have the necessary tool chains for building the LFS system, we'll start with building the LFS system with the necessary packages. And before that, we need to enter to chroot. To do that, basically this is the command, and we need to we need to enter the command as the root user, the sudo. Yes, password is okay. Well, now we are in the uh, chroot, and we can start building the LFS system. Okay, and chapter 8 is installing basic system software. Introduction. In this chapter, we start constructing the LFS system in earnest. The installation of this software is straightforward, although in many cases the installation instructions could be made shorter for more shorter and more generic. We have opted to provide the full instructions for every package to minimize the possibilities for mistakes. The key to learning what makes a Linux system work is to know what each package is used for and why you may need it, or the system may need it. That's our purpose. We wanted to learn the Linux internals more than we have a Linux distro built with the Linux from scratch. We do not recommend using optimization. They can make a program run slightly faster, but they may also cause compilation difficulties and problems when running the program. If a package refuses to compile when using optimization, try to compile it without optimization and see if that fixes the problem. Even if the package does compile when using optimization, there is the risk it may have been compiled incorrectly because of the complex interactions between the code and build tools. Also note that -march and -tune mtune options using values not specified in this book have not been tested. This may cause problems with the toolchain packages like binutils, GCC, and glibc. The small potential gains achieved in using compiler optimizations are often outweighed by the risks. First-time builders of LFS are encouraged to build without custom optimizations. The subsequent system will still run very fast and be stable at the same time. As we are the first-time LFS builders, we will not use any optimization. Before the installation instructions, each installation package provides information about the package, including a concise description of what it contains, approximately how long it will take to build, and how much disk space is required during this building process. Following the installation instructions, there is a list of programs and libraries along with brief descriptions that the package installs. Note: the SPU values and required disk spaces include test suite data for all applicable packages in Chapter 8. SPU values have been calculated using single CPU core -J1 for all operations. About libraries. In general, the LFS editor encourages building and installing in static libraries. The original purpose for most static libraries have been made obsolete in a modern Linux system. In addition, linking a static library into a program can be detrimental. If an update to the library is needed to remove a security problem, all programs that use static library will need to be relinked to the new library. Since the use of a static library is not always obvious, the relevant programs and the procedures needed to do the linking may not even be known. In the procedures in this chapter, we remove or disable installation of most static libraries. Usually, this is done by passing a double dash disable static option to configuration. In other cases, alternate means are needed. In a few cases, especially glibc and GCC, the use of static libraries remain essential to the general package building process. For a more complete discussion of libraries, see the discussion, okay, libraries, static or shared, in the BLFS book. We will see this in the future. Package management. Package management is an often requested addition to the LFS book. A package manager allows tracking the installation of files, making it easy to remove and upgrade packages, as well as the binary and library files. A package manager will handle the installation of configuration files. Before you begin to wonder, no, this section will not talk about nor recommend any particular package manager. What it provides is a roundup of the more popular techniques and how they work. A perfect package manager for you may be among these techniques, or maybe a combination of two or more of these techniques. This section briefly mentions issues that may arise when upgrading packages. Some reasons why no package manager is mentioned in LFS or BLFS. Dealing with package management takes the focus away from the goals of these books, teaching how a Linux system is built. There are multiple solutions for package management, each having its strengths and drawbacks, including one that satisfies all audiences is difficult. There are some hints written on the topic of package management. Visit the hint project and see if one of them fits your needs. Okay, so some package managers, at least in Ubuntu, what we have is apt, and recently they have a Snap uh, package manager comes along with Ubuntu 2022 edition, 2022 release. Okay, upgrade issues. A package manager makes it easy to upgrade to newer versions when they are released. Generally, the instructions in the LFS and BLFS books can be used to upgrade to the newer versions. Here are some points that you would be aware of when upgrading packages, especially on a running system. If Linux needs to be upgraded, for example, from 5.10.17 to 5.10.18 or 5.11.1, nothing else needs to be rebuilt. The system will keep working fine thanks to the well-defined broader border between kernel and user space. Especially Linux API headers need not to be and should not be see the next item upgraded alongside the kernel. You need to reboot your system to use the upgraded kernel. If Linux API headers or glibc needs to be upgraded to a newer version, example from glibc 2.31 to glibc 2.32, it is safer to rebuild LFS. Though you may be able to rebuild all the packages in their dependency order, we do not recommend it. If a package containing a shared library is updated, and if the name of the library changes, then any packages dynamically linked to the library needs to be recompiled in order to link against the new library. Note that there is no correlation between the package version and the name of the library. For example, consider a package foo 1.2.3 that installs a shared library with name libfoo.so.1. If you upgrade the package to a newer version, 4.1.2.4, that installs a shared library with the name libfoo.so.2. In this case, any package that are dynamically linked to libfoo.so.1 needs to be recompiled to link against lib4.so.2 in order to use the new library version. You should not remove the previous libraries unless all the dependency packages are recompiled. If a package containing a shared library is updated and the name of the library doesn't change, but the version number of the library file decreases. For example, the name of the library is kept named lib4.so.1, but the name of the library file is changed from lib4.so.1.25 to 24. You should remove the library file from the previously installed version lib4.so.1.25 in the case, or a ldconfig run by yourself using command line or by the installation of some package will reset the symbolic link lib4.so.1 to point to the old library file because it seems having a newer version as its version number is larger. This situation may happen if you have to downgrade a package or a package changes the versioning scheme of library files suddenly. If a package containing a library is updated and the name of library doesn't change, but the server issue, especially a security vulnerability, is fixed, all running programs linked to the shared library should be restarted. The following command, run as root, after updating will list what is using the old version of these libraries. Replace libfoo with name of the library. So this is the one that it does. If OpenSSH is being used for accessing the system and it is linked to the updated library, you need to restart SSHD service, then log out, log in again, and return that command. Rerun that command to confirm nothing is still using the deleted libraries. If a binary or a shared library is overwritten, the process using the code or data in the library or in the binary or library may crash. The correct way to update a binary or a shared library without causing the process to crash is to remove it first, then install the new version into position. The install command provided by CoreUtils has already implemented this, and most packages use it to install binaries and libraries. This means that you won't be troubled by this issue most of the time. However, the install process of some packages, notably Mozilla JS in BLFS, is just overwrites the file if it exists and causes a crash. So it's safer to save your work and close the unneeded running process before updating a package. Package management techniques. The following are some common package management techniques. Before making a decision on a package manager, do some research on various techniques, particularly the drawbacks of a particular scheme. It's all in my head. It's all in my head. Yes, this is a package management technique. Some folks do not find the need for a package manager because they know the packages intimately and know what files are installed by each package. Some users also do not need any package management because they plan on rebuilding the entire system when a package is changed. Mhm. Install in separate directories. This is simplistic package management that does not need any extra package to manage the installations. Each package is installed in a separate directory. For example, package foo 1.1 is installed in userlink package foo 1.1 and the symbolic link is made from user package foo to user package foo 1.1. When installing a newer version foo 1.2, it is installed in the foo 1.2 directory and the previous link is replaced by symlink to the new version. Environment variables such as path, LD library path, man path, info path, and CPP flags needs to be expanded to include user package foo for more than a few packages. For more than a few packages, this scheme becomes unmanageable. Okay, this is more of a manual process, and of course, this is much more complicated. Let's say Symlink style package management. This is a variation of the previous package management technique. Each package is installed similar to the previous scheme, but instead of making the symlink, each file is symlinked into the user hierarchy. This removes the need to expand the environment variables, though the symlink can be created by the user to automate the creation. Many package managers have been written using this approach. A few of popular ones include Stow, EPKG, Graft, and Depot. Depot. The installation needs to be faked so that the package thinks that it is installed in user, though in reality it is installed in the user package hierarchy. Installing this in this manner is not usually a trivial task. For example, consider that you are installing a package libfoo 1.1. The following instructions may not install the package properly. Okay, with this prefix the user package libfoo 1.1, the installation will work, but the dependent packages may not link to the libfoo as you would expect. If you compile a package that links against the libfoo, you may notice that it is linked to the libfoo.s4.1 instead of lib. Okay, linked to user package libfoo.1 lib instead of user libfoo.so.1 as you would expect. The correct approach is to use the destination directory strategy to fake installation of the package. This approach works as well. So as follows. You configure prefix with user, destination directory is this one. Okay. For the installation. Most package supports this approach, but there are some which do not. For the non-compliant packages, you may either need to manually install the package or you may find it easier to install some problematic packages into opt. Timestamp based. In this technique, a file is timestamped before the installation of the package. After the installation, a simple use of the find command with the appropriate option can generate a log of all files installed after the timestamp file was created. A package manager written with this approach is install log. Though the scheme has advantages of being simple, but it has two drawbacks. If during installation the files are installed with any timestamp other than the current time, these files will not be tracked by the package manager. Also, this scheme can only be used when one package is installed at a time. The logs are not reliable if two packages are being installed on two different consoles. Tracing installation scripts. In this approach, the commands that the installation script perform are recorded. There are two techniques that one can use. The LT preload environment variable can be set to point to a library to the to be preloaded before installation. During installation, this library tracks the packages that are being installed by attaching itself to various executables such as cp install move and tracking system calls that modify the file system. For this approach to work, all the executables need to be dynamically linked without the SUID or SUID or SGID bit. Preloading the binary may cause some unwanted side effects during the installation. Therefore, it is advised that one performs some tests to ensure that the package manager does not break anything and logs all the appropriate files. The second technique is to use strace, which logs all system calls made during the execution of the installation scripts. Creating package archives. In this scheme, the package installation is faked into a separate tree as described in the Symlink cell package management. After the installation, a package archive is created using the installed files. This archive is then used to install the package either on the local machine or can even be used to install the package on other machines. This approach is used by most of the package managers found in the commercial distributions. For example, example of package managers that follow this approach are RPM, which incidentally is required by the Linux standard B specification, PKG utils, Debian's apt, and Gento's portrait system. A hint describing how to adopt this style of package management for LFS system is located at this uh, URL. Creation of package files that include dependency information is complex and is beyond the scope of LFS. Slackware uses a tar-based system for package archives. This system purely purposefully does not handle package dependencies as more complex package managers do. For details of Slackware package management, see this URL. That's okay. This is not the scope of what we're doing now. User-based management. This scheme, unique to LFS, was devised by Matthias Beckman and is available from the Hints project. In this scheme, each package is installed as a separate user into standard locations. Files belonging to a package are easily identified by changing the user ID. These features and shortcomings of this approach are too complex to describe in this section. For the details, please see the hint. Okay. Deploying LFS on multiple systems. One of the advantages of an LFS system is that there are no files that depend on the positions of files on a disk system. Cloning an LFS built to another computer with the same architecture as the base system is as simple as using tar on the LFS preparation that contains the root directory over 250 MB uncompressed for a base LFS build. Copying that file via network transfer or CD-ROM to the newer system and expanding it. From that point, a few configuration files will have to be changed. Configuration files that may need to be updated include etc hosts, etc fstab, etc password, etc group, etc show, shadow, etc ld so config, etc sysconfig rc site, etc sysconfig network, and etc sysconfig ifconfig h0. The custom kernel may need to be built for the new system depending on differences in system hardware and the original kernel configuration. Note there have been some reports of issues when copying between similar but not identical architectures. For instance, the instruction set for Intel system is not identical with ARM processors, and the later version for some processors may have instructions that are unavailable in earlier versions. Finally, the new system has to be made bootable via the section 10.4 using grub to set up. This we will do once we build the LFS. We'll start building from man pages uh, 5.3. The man pages package contains over 2200 man pages. Approximate build time is less than 0.1 SPU. Required disk space is 33 MB. Installation of man pages. Installation man pages by install man pages by running the below command. Okay, let's extract. I hope I think we need to go to sources, sources directory. Okay, now we have the uh, packages here. Then tar xvf to extract man pages 3. Okay, it's extracted. Then we go cd to man pages, and then we give this make prefix because man pages is just a documentation. So it doesn't require to be built as such as we build for source files. We just have to install. Install here means that copy uh, all these man pages to the appropriate location. Well, now it is done. Content of man pages, installed files, various man pages. Man pages. It describes the programming language functions, important device files, and significant configuration files. So basically, that's manual pages contains. Okay, the next package is Lana IANA etc 2022-2207. The IANA etc package provides data for network services and protocols. Then come back and then remove the man pages directory. Then tar xvf extract the IANA etc. Well, it's installed. Sorry, it's extracted. Change, move to IANA directory. And then the approximate build time is zero point 0.1 SPU. Okay, it's quite simple. So for this package, we only need to copy the files into place. Okay, CP services protocols to EC. Okay, that's done. And the contents of IANA etc protocols and etc services. Short descriptions. If you see, it just has the services and protocols directory. Describes the various DAR APA internet, okay, uh, DARPA internet protocols that are available from TCP/IP systems, so subsystems, and the services provides a mapping between free friendly textual names for internet services and their underlying assigned port numbers and protocol types. Next is glibc. As we know, glibc package contains the main C library. This package provides the basic routines for allocating memory, searching directories, opening and closing files, reading and writing files, string handling, pattern matching, arithmetic, and so on. So approximate build time is 24 SPU. It's going to take a very long time and require disk space 2.8 GB. Installation of glibc. So first we will come out of the IANA directory. Let's remove the IANA directory and then tar xvf glibc dot tar. Okay, some of the glibc programs use the non-FSH compliant var_db directory to store their runtime data. Apply the following patch to make sure such programs store the runtime data in the FSH compliant locations. So there is a patch that was provided. So basically we need to provide. run the fix. Okay, now let's cd to glibc, apply the patch. Okay, patch is applied. The glibc documentation recommends building glibc in a dedicated build directory. So we create m sorry mkdir-v for verbose. We want to see whether the bu build, then cd build. Ensure that the ld config and SLN utilities will be installed into user bin. So echo roots directory root sbin dir to user sbin. So basically we are putting this line into config params file and prepare the glibc for compilation. Okay, let the configuration run. Meaning of the configure options: disable WError. This option disables the WError option based on GCC, so pass to GCC. This is necessary for running the test suite. Enable kernel 3.2. This option tells the build system that this glibc may be used with the kernel as old as 3.2. This means generating workarounds in this case. Sorry, workarounds in case a system call introduced in a later version cannot be used. Enable stack protection strong. So this option increases the system security by adopting extra code to check for buffer overflow such as stack smashing attacks. With headers user include, this option tells the build system where to find the kernel API headers. libc cv slibdir is user lib. This variable sets the correct library for all systems. We do not want lib64 to be used. Then we compile the package with make. In this section, the test of GCC is considered critical. Do not skip it under any circumstance. Okay, probably it'll take more time to check. Well, first we will do make for compilation and wait for some time. Okay, generally a few tests do not pause. Okay, let's see this once the make is done. Okay, now the build is done. In this section, the test suite for glibc is considered critical. Do not skip it under any circumstance. Okay, let's do make check to run some tests. Okay, it may seem some test failures. The glibc suite is somewhat dependent on the host system. A few failures out of over 4,200 tests can generally be ignored. This is a list of common issues seen for recent versions of LFS. Okay, but what I can see is a lot of tests failed. Couple of tests, I would say. Dev FT3. Anyways, let's see. IOTST LCH mode is known to fail Okay, TTY name, that's fine. Though this is harmless message, the install stage of this glibc will complain about the absence of etcld.so.conf. Prevent this warning with, okay, just create a dummy config file. Anyways, let it run. Well, now that the build is, the tests are run, uh, there's error 1, leaving directory. What's the error? Okay, 54 tests failed and 4900 tests passed and 121 unsupported. That's okay. I will not get too much into this. Okay, these are the tests that failed. NDPLS pre-thread cancel exited, pre-thread kill exited. Okay, there are few tests that are failed. Mm, it looks it's more than what is listed here. You may see some tests failed. The glibc test suite is somewhat dependent on the host system. A few failures out of 42,000 tests can generally be ignored. So I would say 54 is a few, and out of, I think, around we have 5,000 tests here. That's fine. So let's move on. Though it is a harmless message, the install stage of glibc will complain about the absence of etc lib.so config file. Excuse me. Prevent this warning with the touch. The touch command is basically to update the timestamp. Also, we can use this to create an empty file. Then fix the make file to skip an unneeded sanity check that fails in the LFS partial environment. So this is something to update the make file. And install the package. Now let's install the package with make install. Fix hard-coded. Okay, now we fix hard-coded path with executable loader in LDD script. It looks like there are some hard-coded parts, then we're going to fix it. Then install the configuration file and runtime directory for NSCD. Okay, and then make dir pv cd. Next, install the locals that can make the system respond in a different language. None of the locals are required, but if some of them are missing, the test suite of the future packages would skip important test cases. Individual locals can be installed using local def program. Example, the second local def command below combines the user share IL8N locals CSCZ charset independent local definition with the user share IL8N char maps UTF8.gz char maps definition and appends the result to the user lib locally archive file. The following instruction will install the minimum set of locals necessary for the optimal coverage of tests. So, okay, let's see what it does. In addition, uh, install the local for your own country, language, and character set. I think that's fine. Okay, something is happening. Let's wait for the command to exit. I'm trying to stop, but it's not stopping. Okay, okay, so it looks like all these are to be executed separately. And then local def POSIX. Okay, so it's going to be a tedious job. Okay, why don't we construct everything, run one by one? Okay, let me not do that. Let me just run everything one by one so that I know this is for Europe. I know this is not efficient way of doing it, but I'm doing. Ideally, I would take this in a text file and then create a script to execute all of this. That would be a better way, but it's okay for now. And let me just check if that works. Going to Hong Kong and PH. Well, so let me try PH. Okay, let's see again what it tells. Then Europe. It looks like these are some of the language packages specific to the country, I would say. JP could be Japan, not sure. But anyways, I will do it. Otherwise, the test would fail. So that is something which I don't want to uh, let it happen. So we're almost done. Now this didn't take much time. Probably I did for all the languages that are listed here. It's like the language and the character set. Oh, that's the thing. Normally, I mean, we use US or and UTF-8. That should suffice, but that's okay. And alternatively, install all local listed in the glibc 2.35 local data supported files. It includes every locally listed above and many more at once with the following time-consuming command. Okay, probably it would take some time. That's okay. We have all the time. Okay, done. Yes, entering directory. Okay, let's wait until it's done. Okay, now we will configure GCC. Adding nswitch.conf network switch. The etc nsswitch.conf file needs to be created because the glibc defaults do not work well in a networked environment. Create a new file, the etc nsswitch.conf by running the following command. Okay, so here uh, I think this contains the password group shadow. Basically, this contains for the protocols, network related information. Adding time zone data. Install and set up time zone data with the following. Okay, these are data. So let's extract it, and the zone info is the zone info. User shared zone info. Basically setting this variable here. The make dir pv zone info POSIX write POSIX and write. We're creating this directories. Then for gsat. Okay, so let's. This is basically one command. Okay, so all of it's done. So basically here when you use for, you need to finish with done. So that's the idea. And I think here we have uh, created, basically we have setting the time zones here. So for TZAT in etc, South America, North America, Europe, Africa, Antarctica, Asia, Australia. For all this, we are doing the time zone setting. Then we do a copy time zone tab. These are the things that we copy to time zone info. So I think it is copied. ZIC. Let's just check what ZIC is for the Linux command. Okay, unset this zone info. So we are unsetting the zone info that we set in the above line. So let's just search Google, see what ZIC Linux command, what it does. Oh, not zip. Okay, ZIC reads text from the file named on the command line and creates the time conversion information files specified in this input. Okay, so I think in the zone info, uh, in this directory, we will have the time zone information. So, and I think it converts to the time zone file. Okay, the meaning of ZIC command. ZIC-l dev null. This creates POSIX time zones without any leap seconds. It is conventional to put this in both zone info and zone info POSIX. It is necessary to put the POSIX time zones in zone info, otherwise various test suites will report errors. On an embedded system where space is tight and you do not intend to ever update the time zones, you could save 1.9 MB by not using POSIX directory. But some applications or test suites might produce some failures. ZAC in leap seconds. This creates time right time zones including leap seconds. On an embedded system where space is tight and you do not intend to ever update the time zones or care about the correct time, you could save 1.9 MB by omitting the right directory. ZIC-P. This creates POSIX rules file. We use New York because POSIX requires daylight savings time rules to be accordance with US rules. One way to determine the local time zone is to run the following script. Okay, maybe I'll show you what happens here. I will not run as in the chroot. Okay, probably in case if it exists, let's see. Okay, you see, select the content. Here we are in Asia, and the option is 4, and I'm from India. Where is I-15? Well, the following information has been given. India, therefore TZ Asia Kolkata will be used. Go information OK, then you press 1 for S, and you see here is the TZ value again. This is standard output so that you can use the user bin tz command in shell script Asia Kolkata. So that's how it works. That's fine. I'm not going to change it. So after answering a few questions, yeah, like this, it produced the output. Then create the etc local time file by running ln okay sfv user share time zone info xxx etc location. Replace xxx with the name of the time zone selected, example Canada Eastern. I can do this. So paste. But what I will be doing is I will be removing this info with Asia Kolkata. Okay, now the local time is set to Asia Kolkata, even in our build. That's fine. Configuring the dynamic loader. By default, the dynamic loader uh, lib ld Linux start Soda 2 searches through lib and user lib for dynamic libraries that are needed by programs as they are run. However, if there are libraries in directories other than lib and user lib, these needs to be added to the etcld.soconf file in order for the dynamic loader to find them. Two directories that are commonly known to contain additional libraries are user local lib, and oplib. So add these directories to dynamic loader search. Create a new file etc ld.soconf by running the following command. Here we're basically creating the conf file and then adding these two directories, user local lib and oplib. If desired, the dynamic loader can also search a directory and include the contents of files found there. Generally, the files in this include directory are one line specified the described library path. To add this capability, run the following command. So we're basically updating. Okay, let's get. So basically, the single dash is to add from the beginning, and here double, um, I would say greater than symbols is to concatenate. That's the idea. That's how the cat command works. Okay, and make dir. We're creating a directory for etc ld.soconf.d. Okay, then contents of GCC. I think we have seen this in our earlier sessions, and I will not uh, rerun or reread all this. So that's fine. This basically concludes this session. or this episode, please subscribe to this channel and leave your valuable comments or feedback in the comment section. Thanks for watching.